Morning, I'm Jeff Hammond, Executive Director at IGSHPA. Welcome to our April Town Hall. We're honored to have Terry Proffer, who's a frequent presenter for these town halls and Dig Deeper sessions. It's an exciting session this month. I'll talk about here in just a moment. But before that, if you'll bear with me here, I have some of the latest IGSHPA news. And so we'll go through a few items and I'll introduce Terry and then turn it over to him for the presentation. So this is a town hall we have once a month, as well as a Dig Deeper webinar, which is also once a month. And at this point, we have filled all of our town halls with speakers, but we do still have a couple of Dig Deepers left. The note here on the right-hand side shows August available, but we just filled that one. So if you're looking at presenting, we do have September and October open for Dig Deepers. Those are just a little bit different flavor from the town hall. The town hall is a little bit of a broader topic. Dig Deeper typically is a little more technical in nature. So if you have a topic you'd like to present, just go to IGSHPA.org, click on the events and training menu, and you'll find this form for submitting your abstract. Also, we still have sponsor openings for town hall and Dig Deeper. So if you'd like to get your company name out there, remember we do record these sessions. So your company logo and name will be out there for as long as they're online. Some updates on the conference. We have the 2023 conference registration live now. So you'll want to register for that. It's in Las Vegas, again, in coordination with NGWA, National Groundwater Association, and it's December 5th through the 7th. So check that out. Also, exhibitor booths are available, and we have sponsorships for the conference and advertising opportunities. You can see here we are already getting some sponsors. We certainly appreciate Climate Control Group as our platinum sponsor. We already have 2 gold sponsors, Centennial Plastics and Water Furnace. There's only 1 gold sponsor left, so you'll want to check that out if that's something you're considering. And we thank Concord Engineering and Intertech Global for silver sponsorships. There's still 2 of those available. Our diamond sponsorships available, and we have 5 bronze sponsorships. So we are filling up quickly. Appreciate everybody's interest in the conference and support for sure. Same thing on booth space. You'll notice we already have a couple of 20 by 20 booths, a 10 by 20 and one 10 by 10. So still quite a bit of real estate left there, and these can be configured however you like. So if you want the whole block or just 1 booth or 2 booths or however you want to do that, those are configurable. The main entrance is over here on the right-hand side, and also you can't see it, but there are doors which would be right here. So as people come into the space, they can go forward to the main NGWA aisle, or they can go left directly into the IGSHPA pavilion. So this is a good location, and if you're thinking about exhibiting, you'll want to make sure you get your reservation in quickly. For advertising opportunities, the program guide, if you remember, each year we have a program guide that provides information on speakers and presentations, but there are a lot of space in there for ads. So we still have quarter page, half page, and full page ads, and the inside front cover has not been taken, nor the back cover. So check that out on IGSHPA.org. For the conference, we've already received a lot of abstracts, and we are still taking abstracts until May 31st. At that point, then we'll be reviewing those abstracts, and we should have some decisions late June, early July for the speakers for our conference. So if you would like to speak at the conference, make sure you go to IGSHPA.org and scroll down. You'll find a paragraph that talks about conference presenters. Get those in before the end of May, and we'll take a look at the topic that you're suggesting. Keep in mind that this town hall and our Dig Deeper webinars are eligible to help with your CEUs for certification. So if you'd like to get credit for attendance here, just make sure in the chat that you put your name and your email address. If you put both of those, name and email, and then we'll make sure we give you credit for this town hall. Just a little bit of housekeeping. We use the chat for any speaker questions. So as Terry's going through his presentation, if you think of something that you'd like to ask, just type it in the chat. And at the end of Terry's presentation, if we have time, then I'll read all those questions and Terry will be able to respond. If we don't get to your message today, we'll do our best to get back to you after the conference. We'll keep track of those questions, get with Terry, and then we'll follow up. Also, please mute your microphone unless you're speaking. It does help with any background noise, and make sure that everyone in attendance can hear that presentation well. We are going to be recording this session, so go to IGSHPA.org. There's an icon at the very top that has the YouTube logo, and that's usually online a couple of days after the presentation. So by the end of the week, if you go to that YouTube channel for IGSHPA, you'll find this presentation recorded. And one more slide before I do my introduction of our speaker. I do need to make sure that everyone's aware the upcoming presentation represents the opinion of the presenter and does not represent any official position, opinion, or endorsement of any products or services by IGSHPA or its members. IGSHPA town halls and Dig Deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry and are not meant to endorse one technology or brand over another. It is the presenter's responsibility to disclose any conflict of interest or position that may arise in the content of the webinar. All right, so now let me change over slideshows here quickly, and I will introduce Mr. Proffer. We'll get Terry's slideshow up. All right, so we're excited to hear about this project. Terry Proffer is our presenter today. He's been involved in the GSHP industry since 1992. After a career as a petroleum geologist starting in 1979, after graduating with a geology degree from Sul-Ross State University in Alpine, Texas. He's designed closed loop systems for small residential applications to facilities exceeding 350,000 square foot, a little bit of a difference there, of conditioned space, including various commercial, institutional, and military projects. Terry is the manager for Major Geothermal of Wheat Ridge, Colorado, a firm that specializes in the design of closed loop ground heat exchangers, peer review, installation quality assurance, functional testing, and GSHP system forensics. So it's my pleasure to introduce Terry, and you take it from here. Thanks a lot, Terry. I appreciate you joining us today.
Thank you. Appreciate it. Really, this is an honor to be able to present some of Gunnison County's projects. I couldn't have done this without John Cattles, Assistant County Manager for Gunnison County. These guys are the real heroes here for our industry. And some of what we're going to show you, I think, is going to be pretty impressive. This is where the rubber meets the road. What you get with the ground source heat pump system when they're designed and installed correctly. So with that, let's go forward to the next slide. So just where is Gunnison County? Well, it's in the western part of Colorado. It's at the city of Gunnison is at about 7,700 foot above sea level elevation, and permanent population county is about 20,000. So it's sparsely populated, 3,260 square miles, but they're very conscious. The county and the city are very conscious of their conditioning needs for their facilities. Next slide, please. So just a little bit of background on the economy. In the past, mining, timber, ranching, farming, narrow gauge railroad running through that part of the country. More recently, we've got Western State College, so there's quite an educational component to Gunnison, and of course the tourism is everything that you like to do off for outdoors, skiing, fishing, hiking, hunting, that sort of thing. Next slide, please. So, unique things about Gunnison: when you're designing any kind of mechanical system, you have to be aware that it gets cold. So they've got an average annual temperature, including their summer highs, of 35 degrees. So it doesn't get very warm there. over 10,000 heating degree days and almost no cooling degree days. And the lowest recorded temperature, 47 degrees Fahrenheit below zero. That was not a typo. And it's, you know, I've been in Gunnison in the winter when it's a mild winter day of 15 below zero. Everyone's used to it and they deal with it. So it does stay cool. Next slide, please. So this is just a graph from the Desert Research Institute from 1893 to 2016 climate averages. And you can see that extreme minimum green line on the bottom that stays rather frosty in Gunnison. Blue line is the average minimum. Like I say, it is not unusual from November to even early March to have average cold temperatures in the low teens, so it stays pretty cool. Next slide, please. So this is an actual home installation from the 1990s that was actually helped install this system. But what's unique about it is we were able to get one of the first system installations that we were aware of in the Gunnison Basin, and we wanted it sub-metered. So the client tracked his operating costs for his first winter, and for a 3,500 square foot home with a radiant floor with no backup heat, he was under $250 for that winter to heat his home. Kind of funny, his neighbor down the road was telling him that it would never work and came over the furnace. And so Wally, every winter when he sees that propane truck going down to his neighbor, he asks him, how's that propane working out for you? So he has a little fun with it. Next slide, please. So we do have a scattering as an industry of residential installations, various rural areas. Gunnison, there's Crescent, a big ski area, mountain biking in the summer. It's, you know, it's pretty touristy. There's a small observatory, I believe it's with Western State College. And Western State College has their new engineering building that has a ground source heat pump system as well. Next slide. So, John, I believe you're on the call. If you would like to describe why Gunnison is pursuing ground source, I'd like to invite you to comment if you're available.
I am. Thank you. Yeah, my name's John Cattles. Thanks for having me. Yeah, so Gunnison County for a long time has had goals to reduce our greenhouse gas emissions and reduce our energy use at our buildings. And so as we've learned more and began incorporating geothermal into our buildings, we've really come all the way to the point where when we do new buildings or we renovate buildings, geothermal is not just an option, it's our first choice. And we have not been bringing gas service to our buildings, or we've been eliminating it in renovations recently. And we're able to do that in a, as Terry described, a very cold environment. And we feel like we have really good resilience with our systems. We haven't had any issues where we're failing, our buildings are failing in cold temperatures, or where power outages or anything like that have caused problems with us operating our buildings, and especially not compared to our traditional systems that are based on a central plant. We've had much more problems with failures at our central plants that have created emergencies to maintain conditioned buildings. So resilience has become another part of the picture for us. And so a geothermal system based on a distributed heat pump has become the go-to for both for comfort, reducing greenhouse gas emissions, energy efficiency, and resilience.
Thanks, John. I appreciate it. I should have warned you, I was gonna ask you to comment on this. Might have a few more slides too, because it's always best to have the guy that has to live with the system tell people about their experience. Next slide, please. So this is some information on the Health and Human Services retrofit that Gunnison County did, and John provided this information, which I very much appreciate. Yeah, see that slide and look at 2018 forward. There's they really dropped their power consumption on this thing. And John, I'd like to talk a little bit about this real quick. I've actually got a little bit more of a slide presentation on H&H Services building later on, but this data that she provided here, this graph just really is impressive.
Yeah, absolutely. So on this graph, starting at the left, it was kind of our baseline energy before 2009. And we conducted a energy performance contract in 2009 and finished that work in 2010. And you can see that we saved a fair amount of energy in that next bar there in 2013, mostly in natural gas use. But then we had an opportunity to do a renovation at the building in 2018, or need to do a renovation that was going to require us to, move a lot of offices around and walls, and so subsequently our HVAC system was going to be affected. So we took that opportunity to convert the building to a ground source heat pump system. And what we found was we eliminated gas completely, and our energy use, or electric energy use, went up some, but overall energy use was dramatically lower, like 60% lower than our 2013 baseline. And then in 2020, we added a rooftop solar array and cut that energy use from the grid in half again. And the black line on this graph is the estimated greenhouse gas emissions. And you can see that that's also just falling precipitously with geothermal and then the addition of solar.
I also like to remark too that your electricity, that's not just space conditioning, that's all your plug loads, lighting, and everything else in the building, right?
That's correct.
So it's pretty substantial. I've always thought it's been a challenge to get to put people turn net zero, but then I see something like this, I said, I guess it is possible. Pretty good. Next slide, please. So we're going to give some examples of the current installations for Gunnison County. One's actually for the city of Gunnison. And what started this off that I'm aware of, and John, by all means, break in any time here, but the first job that I'm aware of that Gunnison County did was for the county courthouse, which was new construction based on a building that started out in the 1880s, in the Blackstock building, Health and Human Services, which was just mentioned, admin office for the wastewater treatment facility, the library, the airport terminal, and the pending new Gunnison Valley Emergency Medical Service building, which is just a concept right now. Next slide, please. So this is just a perspective from 50,000 foot view, literally, of where these facilities are located. So on the north side of town, we have the Emergency Medical Services building that's yet to be built, library, the Health and Human Services, Blackstock building, which are right next to each other, the courthouse in the middle of town, the airport terminal, and then far out on the southwest is our wastewater admin office. Slide, please. So this is found this on the internet, old photo of the original courthouse built in 1881. It was updated in 2014-15. Condition space is about 46,000 square foot for the new building. Next slide, please. So beautiful facility now. We've got 40 holes, 315 foot deep on this project. It was a bit of a rodeo trying to fit them for the available area. This is the middle of town, so there's already a lot of existing infrastructure. The system was originally designed for 400 foot depth, but we ran into some drilling, ugly drilling conditions, so we had to redesign on the fly. There's 90 nominal tons of heat pump capacity of both water to air and water to water. There's 64 distributed water to air heat pumps. Peak heating load of 52 tons and a peak heating load of 41 heating load tons. And as I'm aware, John comment here, I believe we have a backup boiler, but I don't know if the backup boiler's ever been used.
Yes, we have a backup boiler. We were talked into that on this building, and as our first project into geothermal, we included it. I've never needed it to provide additional heating to the loop. We exercise it routinely, and we do use it for an exterior snow melt application that we are planning to abandon, and we will likely abandon the backup boiler in the next year or two.
Yeah, and by the way, that is controlled to when, if the ground loop were ever to get too cold, the boiler actually tempers the supply water temperature to the heat pumps. So if it's a condensing boiler, if you're only having to maintain like 35 degrees to the heat pumps, you're going to get the peak efficiency out of that boiler. So using the attributes for ground source heat pump system, you can optimize even the backup boiler for help on a system like this. And as John said, doesn't need it. So he has to exercise occasionally, so it doesn't go bad. Next slide, please. So since completion in 2015, this information is provided by John. They're down to 38 cents a square foot per year to, that's all plug loads, power consumption, everything. John, any comments?
Yeah, utility costs have been phenomenal, the savings for us on this project. Maintenance on this building is very easy because of the distributed nature of the heat pumps and the strategy of distributing heat pumps throughout the building. Even if we do have failures, which have been rare, most of our tenants don't even realize that there's been a failure until we're in there fixing it. And so we really like that aspect. It creates a lot more comfort and less complaints from our tenants. And we've also been able to utilize the distributed nature of the heat pumps to try to match our energy load to our energy production with the solar array. And so we're experimenting with staging heat pumps to cycle on and off. So we're not having them all cycle on at one time and creating a high demand and a high demand charge. We're staging those in a way that's flattened our demand curve and really worked nicely with our solar production.
Appreciate it. Yeah, and by the way, with the load profile of that building, quite often that ground loop's not even working at sometimes in the year because that building is load sharing between the packaged water to air heat pumps, which is another advantage of distributed heat pumps. Next slide, please. So I apologize for the photo. I trying to look for something that would give a perspective, but this is the Blackstop building. It's originally built in 1926, and The renovation was completed in 2021. Have about 26,000 square foot of conditioned space. It was a retrofit completed in the building was occupied, so there was some hopscotching around, as I understand it, for people to move around in the building while the system was being updated. So they were running both ground source and conventional systems at different times of the changeover process. Next slide, please. And this is just a layout of the ground loop. We have 30 holes, 340 foot deep. Again, the driller ran into some drilling conditions. We were trying to go to 400, but we had to adjust for the geology for what was fighting the driller with, and have 92 nominal tons of heat pump capacity mixed with both water to water and water to air heat pumps. And there was a vault that was added to facilitate all the infrastructure. Sometimes a vault is necessary to solve other problems, to manage how you're going to run the header piping. The engineer on this project did a very good job on the project, and as I understand it, they've had very good success with this building. Next slide, please. So again, this is from John. They literally have their utility costs. So it's going to a ground source heat pump system for maintenance, their comfort, and the controls, etc. So, John, any comments?
Yeah, you know, I just was, this is the project I think I'm most proud of because it was very difficult. It's an old building. We had to work with the building. We did, and we wanted to respect the historic nature of a lot of the building, interior and exterior. And we were able to do that where this new system is invisible to the user of the building, other than that it just works. It's comfortable in the building. It's much more comfortable than it was previous. And we were able to do this while the building was occupied. The former strategy was a distributed system of fan coils. And so this simplifies the to simplify the process. We developed our building loop, our water loop throughout the building, and then we would move a fan coil one at a time and replace that fan coil with a heat pump that was plugged into the geothermal building loop. And in that way, we were able to slowly decommission the 4-pipe system and bring online the geothermal system and maintain occupancy throughout the whole process.
Thank you. Next slide, please. So you can see the Blackstock building pointed out on the slide, and right next to it is the Health and Services building. Again, this is a retrofit completed in 2018, about 12,000 square foot, and formerly known as Family Services building. John, correct me if I'm wrong, it is now Gunnison County Health and Human Services.
That's correct.
All right. Next slide, please. So we have 18 holes on this project. We started learning our lesson about drilling, and by the way, not all of these projects. This is been quite a few engineering teams on these projects. They've all done a great job. But because of the other drilling issues, we decided to limit our design depth to 350 foot because we figured, hey, we're in the same geologic regime. Let's shorten it up a little bit. By the way, every one of these projects had a thermal conductivity test. So there's 38 nominal tons of heat pump capacity with 8 water to air heat pumps take care of the conditioning of the facility. Next, please. And this is John Graff of the Health Community Services Building. And he just keeps dropping his utility costs on this thing, including ground source and the solar. It's you know, it's pretty hard to argue with this kind of success. I mean, it's definitely impressive to me. Next slide, please. So this is for the city of Gunnison. It's not for the county. It's their new administration office for the wastewater treatment facility. It's about 2,300 square foot. And very small office, not a real big facility. And this contractor is a local mechanical contractor. It's first installation. And we a little skittish about this, but the design was pretty good. You know, we did help them out with a little bit of on the job training on startup and whatnot. But it's pretty nice. Next slide, please. So this is an aerial view. I actually asked if we could get into the water on the wastewater treatment plant, put a heat exchanger in, but powers that be said no. They didn't want anything in the wastewater, and I said okay. So a vertical loop was installed. We had 5 holes by 300 foot. We've got into water for most of the depth right next to the river, and drilling conditions were a little bit ugly, but because we have water moving through most of the column of the boreholes, I don't think that ground's are going to get under 50 degrees. It's just coasting. So we've got 5.5 feet cooling guns for cooling load and 9 feet heating load guns for heating. 12 nominal tons of water to air pumps. They do have backup electric strip heat, but again, that's never been required that I'm aware of. Next slide, please. So we don't have this sub-metered, and I don't have access to the utility bills, but we did run a projected operating cost with our standard software. And we believe that conservatively, just for space conditioning, including pumping power, we're under $500 a year for this building. The only maintenance that's been required that I'm aware of is replacing air filters. Those complaints, and those give the industry, if there is a problem, you do hear about it, but no news is good news for us. And the mechanical contractor that did the installation did a really good job. We thought about servicing the heat pump. Do not throw your refrigeration gauge on the heat pump. That's your water side to check things. We did do a functional performance test. We'll start up on the heat pumps. The thing is copacetic, and to my knowledge, I haven't been out there in a couple of years, but I understand it's working just fine. Next slide, please. I'm very proud of this project. You're going to see why here in just a bit. So this is the new Gunnison County Library, about 15,000 square foot of conditioned space in construction, and recently opened up for business. Next slide, please. So we got into a little bit easier geology. In fact, we have some high thermal conductivity values. In fact, when we got the EC test back, I was pretty amazed. We got 36 normal tons of heat pump capacity. They're all distributed water air heat pumps. 16 peak cooling load tons and 24 peak heating load tons. And this is a decoupled ground loop, by the way. So the ground loop does not work unless it needs to temper the interior building water temperature. Next slide, please. Nice mechanical. I'd like to use this facility for training. It's that nice. Properly labeled. It's easily accessible. And those of you in the industry, you've got to, I think most people agree with me, if you make everything accessible, for some reason your maintenance goes down. You don't have many issues given everything's so easily accessed. So there's some comments here. I don't know if Drew is on the webinar, but Drew Brookhart is the executive director for Gunnison County Libraries. And if you look there, December and January, their electric bills were $62 and $72 per month, respectively. Of course, if you have PV on this thing, but even so, the solar wasn't operating during December and January. And this is a 15,000 square foot building, and including plug loads and lighting, they're under $100 a month. In Gunnison, Colorado. And John, I understand this was been a pretty cold winter, even for Gunnison.
It's been very cold this winter. There was multiple weeks that nights were 15 to 20 below during that January period, with a $72 energy bill. So very incredible results from this project.
The entire design team and contractors, everyone pulled together. Great communications during design and construction. And the system working a lot better than we projected. And if you'll notice on the bottom of the slide, the basis of design for the ground was a minimum of 35 degrees to the heat pumps, which the drain sheet pumps will thrive on. I think we've got a little more water flow into running through some of the formations. So I've been told it's never been below 42 degrees feeding the heat pumps when the injection sides are working. So the system is working really nicely. Next slide, please. Now this is not quite complete, but I'm aware of, but this is the renovation for the main aviation terminal at the Gunnison Regional Airport. This airport services pretty good sized aircraft with a tourist range for the skiers and whatnot, like 737s, that sort of thing. Condition space is about 42,000 square feet. Next slide, please. So we've got 32 poles by 400 foot on this one. Smooth sailing for the ground. We're going to do that very shortly. 65 nominal tons of heat pump capacity between water to air and water to water heat pumps. 8 peak cooling load tons and 16 peak heating load tons. And might ask, well, if it's so cold, why do you have so much cooling? Well, you have to account for a commercial building when it's filled up with people. So even though an airport terminal is not filled up with people all the time, the system has to be sized for when it does have a lot of occupancy on traffic. Next slide, please. So the engineer's analysis from his initial energy report, all utility costs for electricity from elevators, lighting, plug loads, space conditioning, that's maybe be about $70,000 a year. So $1.67 per square foot, which in this type of building, that's not bad at all. The estimated cost for space conditioning is 24% of that, about 40 cents per square foot per year of conditioned space, which is falling right in line with some of the other Gunnison County projects. Again, we don't have any maturity on the system yet. In fact, I don't know, John, if it's even open yet. Well, the terminal is open. I don't know if the retrofit part is open, but we expect that when it's all said and done, the operating costs will be falling in line with the facilities as far as cost per square foot per year. We are predicting a very high efficiency on the heat pumps for cooling of the VPR of 14.9 and an average of heating of 3.8 COP. So we're expecting a very efficient system out of this project. And so-
Yeah.
Oh, I'm sorry.
No, I was just gonna add to that. We have operated that system throughout the winter, this winter.
Oh,
And
okay.
and it's only been 3 months now, but our initial results are actually exceeding the projected results from the engineers. We have had, as most new buildings, we have had some adjustments we're making, and we expect that we'll actually get more efficiency out of the system as we get these adjustments kind of optimized. But yeah, the building's going to perform better than what it was projected by quite a margin. I expect that, I'm guessing right now, but I expect our operating costs will be around $1 a square foot. So 50 cents less than what was projected.
But that's good news. Now that projection of 50 cents square foot, that's all, well, it's not just space conditioning, it's lighting and everything, right?
That's all loads. Yeah. And
All in.
yeah. And that even includes providing conditioning to airplanes as they sit at the ramp.
I don't know how we're going to claim a ground source heat pump system is conditioning airplanes, but I like it.
Yeah, that's electric, but the load is still there. Yeah.
Sure. Yeah. I guess I was stretching that a bit. All right. Well, this project was not without its challenges as far as the ground is concerned. When we punched the test hole, it went down easy. We had a very high TC value, good undisturbed temperature, very happy with it. But when we went into production drilling, we ran into some issues. Next slide, please. So the driller was losing fluids, he was breaking drill bits. Well, what we found out was part of the loop field was sited over the old Denver and Rio Grande narrow gauge railroad maintenance facilities. So there's a railroad shop, turntable, and a switch yard. And we found it. So it was quite a challenge. So you try to account for everything that you can when you start putting in a loop field, but sometimes you get bit. And to the driller's credit, he did deal with it. We had to drill some sister holes on some of the project, but he made it like this. Now, this is the pending new Gunnison Valley Emergency Medical Services building. It's in concept right now. It's not built yet. It'll be about 18,000 square foot, and it will have apparatus space for emergency services needs. Next slide, please. We expect to put in a vertical ground loop. Right now, the concept is to have radiant floors using water and water heat pumps to warm them up. Water air heat pumps for the rest of the building. And if we have enough load out overlap, which I think we will for some parts of the year, we will do a decoupled ground loop system. Next slide. So I think we're actually in good shape here time wise. About the end, I just have a few comments and then I'll leave the last comments with John before we take questions. But one of the things we found in the Rocky Mountains from Canada through Rockies down through New Mexico, that the harsher the winters or even the harsh summers, the more value to get out of the ground source heat pump system. I think the slides and operating performance that John has described really magnifies that. We've also found, not just because it's a rural installation, but try to design your systems as simple as possible, but no simpler than is necessary. Rule of thumb doesn't cut it. you'll get bit every time, most times. You only have to account for your site, geology you're dealing with. You also have to consider what your local contractors can do. So you can't design a system that no one can, that they can install it. It makes no sense. And I'm a big fan of not just making sure that phones work and whatnot, but test the heat pumps upon completion, because it gives you a benchmark for maintenance in the future. It also proves that the system worked the way it was designed. And if you can track the equipment costs, the client can do that. It's going to really prove that everyone made the right decision. And the other thing from the industry standpoint, if you have these successful installations, they're going to lead the door, as we're finding with Gunnison County. Next slide, please. I'll turn this over to John.
Yeah, thank you. Yeah, some of the lessons learned that I've learned is that through the last several projects is we need to make sure our mechanical design team understands ground source heat pumps. They understand the limitations and capabilities, and they don't try to plug a ground source system into a traditional strategy. And so, I say you can't plug a ground source heat pump engine into a traditional HVAC. In my opinion, the distributed systems have many advantages to how you operate a building, and those advantages align well with the capabilities of geothermal systems. And the opposite is also true. They have limitations that make centralized systems that are based on geothermal, while still it works, it doesn't take advantage of all the capabilities at the same rate. We've found in our area, we have to make sure our heat pumps are rated for extended range of operation. We do sometimes see low water temperatures on our loops, and there's products available that have been able to operate at those low temperatures quite well. We really like load sharing, and that goes along with the distributed heat pump strategy, and it fits with the architecture as well. We want to make sure that as we're thinking about the building holistically, and we're understanding how loads vary throughout the day as the sun moves through the sky, that we're building our heat pump strategy to take advantage of that variable loading. Another lesson we've learned is that we need to really communicate clearly with our design team and the mechanical team about our expectations about performance, and not have them make assumptions on our behalf about what those expectations are. We've found sometimes systems can be over designed, and when we ask the question about why and what assumptions went into systems and the design choices, we can come to solutions that are more right sized for our needs, save us money, save us in energy over the long term. And so, one of the goals I have is, as we start projects every time, is to really get those parameters and some assumptions out on the table early. And I'll give an example with design that we're working on now that Terry mentioned with emergency medical services building. There's an assumption that we need to recover the heat in the bays needs to recover very quickly if we open a bay door to have an ambulance leave. And as we've been discussing this with the EMS teams, that's not necessarily true. We don't need to have that heat recover within 5 or 10 minutes. And so we're looking at a strategy that relies a lot more on the in-floor radiant heat, and we're not focusing as much. We do have heat recovery, but we're not, that system doesn't need to be sized to as large of a size to recover instantly if a garage door opens. So we're really thinking about how we actually use buildings, what the operation of those buildings is, and trying to meet those needs and not make assumptions about needs that might not be true. The last thing I would say is on the last tab on there, especially in new construction, but it's true in renovations too. Borehole drilling is a mess and it can be very disruptive to a site. So you have to think about how you're going to fit that into the design schedule. We prefer to do the borehole drilling before we start other site work on site. We prefer to get those bores drilled, stubbed out, and the site cleaned up so that we can we have to work around those bores throughout the project, but it's much easier to do that than it is to disrupt the site with borehole drilling during other construction activities.
Yeah, it's not like they're over in small 8 foot by 30 foot, not counting support vehicles. So it's quite a rodeo when the drillers show up. So that's a nice thing. John, he understands this. So if I'm on a design team, we're able to emphasize this in early, so it's out of everyone's hair. But thank you, John. I really do appreciate it. I mean, this is why I wanted to make a presentation on guys, what you guys have been doing, because it's really where the rubber meets the road. So with that, I guess we're open for questions.
Great. Well, thanks, Terry and John. We need to figure out how to get you two on a speaking circuit to other county managers throughout the country, right? So we do have quite a few good questions here. One of them has already been answered, but I'll go ahead and read it just in case not everyone saw the chat. Jackie asks, when you say a backup boiler and heat to the loop, do you mean the building loop or the earth loop? And John answered, it was the building loop. So it's not the earth loop. Yeah,
you don't want to waste the heat, because a lot of people, and we've seen this on people not familiar with technology, designing a system, don't think they need to keep the ground loop up. Well, we'll just waste that heat. So what you want to do is temper the supply water temperature to the heat pumps in the backup boiler. And like I said, if you keep it at 35 or 40 degrees, the condensing boiler really gets along with that very well. So stays very efficient, not wasting heat off the ground loop.
Excellent. All right. Well, Victor asks a question for John. You specifically mentioned GSHP with distributed heat pumps as a preferred system and mentioned issues with existing central plants. Could you clarify the type of central plant installed and if you have considered centralized water-to-water ground source heat pumps when considering retrofit of existing plants?
Yeah, so we have several buildings with various systems, but what I can tell you from experience operating these is that, for example, a building we have with a central boiler, a central chiller, a 4-pipe system, and VAVs, that building oftentimes I'll pull up to that building, especially at the shoulder season like now, and I'll see both the boilers and the chiller running at the same time. And consequently, what's happening with the controls to make that work and provide comfort to the occupants is a lot of gymnastics. There are controls trying to modulate VAVs, modulate valves for coils that are either cooling or heating throughout the building, and it never works exactly right. It's just overly complex. And what I've found in comparison to our distributed heat pump systems is that it's very, very simple. When we're able to do a distributed system with heat pumps matching zones, it simply runs off of a local thermostat. We do have controls that are monitoring that, and we control the pump, the loop systems, and our air exchange systems. But the controls complexity is orders of magnitude more simple, and therefore it just works more efficiently. It's easier to optimize and easier for us to maintain occupant comfort. So yes, we've considered replacing, central plants with boilers, or boilers with a like a water to water heat pump or something like that. But that would be, I would consider that a compromise position that we would only take if we really had no other choices.
That's great information. I've always thought they were simple, but I'm a little biased. So it's good to have that validation that this is the simplest system. Dean asks a question: do we know the cost of the geothermal installation and how long the return on investment will be? I guess Terry or John.
I'm gonna have to look that, John, because I'm always at the bottom of the food chain, so I never see all the final costs.
Yeah, I do have costs, and these costs are going across a number of years starting in 2014, and I haven't adjusted these with inflation. So our earlier projects our all-in cost for the HVAC system was around, it was $43, varying between 43 and 49. The last two projects we've done post COVID and all of the inflation that we've experienced, one was about $55 a square foot, and the other was $61 a square foot. So I don't find those to be that far off of what we've seen in estimates for traditional systems, and those costs include the ground loop and all of the mechanical systems in the building.
Great. We have about a minute left. It's up to you, Terry and John. Do you want to stick around for a few more questions, or should we record these questions and get back to everyone? I don't know if you have the time or not.
I am available, but
I am too.
Helps.
Okay, great. Well, then we'll just we'll get through a few more here. I want to be respectful of everyone's time, but there's a lot of interest here. So if we can answer just a few more, that'd be great. This question's for Terry. Could you please elaborate on the geologic conditions experienced at depth in the Gunnison area that precluded achievement of the total planned borehole drilling depth of 400 feet?
Yeah, we had a couple projects where we ran into some alluvial conditions at depth that the driller was not expecting, but most of these drillers that drill in this country can deal with it. But sometimes you run into unconsolidated glacial till, things like that, and they were losing their drilling with mud, and they were losing drilling fluids. They just couldn't get returns to the surface, and it just we came up with solutions, but then it was going to cost a lot more to complete to the design depth. And so what we did was we looked at it. Okay, let's see where we're at. Let's run a TC test at this depth, and we redesigned on the fly for production drilling. So instead of and I'm just pulling numbers out of the air here, instead of $15 a foot to complete the whole to 400 foot, we've been literally gone to like $25 or $30 a foot. So that made no sense when we had the space to put shallow boreholes. So you don't have that in every part of the county, but you have to remember this is the Rocky Mountains. So we have a lot of varied drilling conditions, and they can change rapidly. For example, the library, we're not that far from the Blackstock and Health Services building, but the drilling, we noticed some sedimentary rock that was easy drilling, and actually had higher thermal conductivity play there. So when we started installing ground source sheet pump systems in the Gunnison area, we really didn't have a lot of deeper drill data. We have shallow water well data we found, but we really were hitting the line when we first started one for the county courthouse.
Okay, great. Victor had a similar question, and I believe you answered his question when you answered Jennifer's question. Victor has another question. What are approximate annual load balances for these projects given cold climate? Are they heating dominant? If so, how are you balancing annual load on the ground loop to avoid year-over-year temperature reduction to keep the ground loop length economical, or are you using auxiliary heating equipment?
That is a very good question. And that goes back to the myth that everyone believes that if you have an unbalanced load, you'll eventually freeze up a loop or overheat it. Nothing could be further from the truth, because we have heating only systems that we never freeze up the ground loop. We have cooling dominated loops that you would expect when you look at the software simulations that, you know, in 10 years or whatever, you're going to overheat a loop. So what we do to verify that our ground loop designs, and this isn't just me because there's other people designing ground loops on this project, on these various projects. We'll do a little trick where we'll take out, if the load is heating down, we'll take out all cooling of the load and we'll run our simulations with all heating or all cooling only to look at how the loop might perform. And we'll adjust our number for that reason, but never going to get perfectly balanced load. And I realize that a lot of people that advocate you got to make a balanced load and the ground load's going to fail at the time. Nothing could be further from the truth.
Great perspective on that, Terry. Ben asks about sharing this presentation. This is recorded, and so you certainly can watch that YouTube video. If you're interested in the presentation, just send an email to info@IGSHPA.org, and we'll follow up with Terry and John on that. If you'd like the presentation, we'll need to get permission for that. Another question for John from Victor. For your larger buildings, are you worried about distributed maintenance versus centralized of distributed heat pump systems?
Yeah, there is some more maintenance with distributed systems. When we have to go throughout a building and change air filters, that's definitely a little bit more labor intensive than it would be going to an air handler, on the roof or in a mechanical room and doing it in the back where we're not affecting anyone. But we haven't found it to be a very big problem. In fact, my crews just finished switching over the air filters in the courthouse where I'm at now last week. It took 2 guys 2 days, and they did the annual maintenance and air filter change throughout the building. It's a little longer than it would take, in other buildings with centralized systems, but we've been able to adapt pretty easily. And then just generally with the heat pumps just don't have as much maintenance requirements either. And so really it comes down to verifying, we do verify some performance. We want to make sure that everything's working well, and then we change the air filters. And that's kind of it.
That's a good thing. All right. Brian asked a question, what antifreeze were you using in your loops, and how cold did your loops get?
Most of the systems have more than, none of them have more than 25% propylene glycol, because we ran those numbers on everything. Make sure that we weren't getting into laminar flow on these. But John, you comment too. I just know that the library has never got below 42 degrees supply water temperature, even though we designed the field for minimum of 35 degrees. We did have a few more boreholes for safety factor, so that helps.
Yeah.
Most of the projects that I'm aware of, I've been involved with, most of these things in most cases were running plus or minus 40 degrees in first case.
Yeah, that's been our experience. And that's actually something that we've had to negotiate on a couple of projects with mechanical engineers, and then, Terry designing the loop field. Often mechanical engineers revert to a higher concentration of glycol. But once we start to work through the fact that there's nothing exposed outside air in these systems, we can reduce that concentration significantly, which increases the efficiency of the system and consequently reduces our bore field sizing. So we try to find the right balance. We are in an area where water quality is really a big concern, and so we, as a belt and suspenders thing, we've been using a food grade rated glycol just in case there were to be a problem. That's just such an extremely low risk. We don't feel that that's something we worry about too much, but why not put some food grade glycol in the systems just in case. The lowest temperature I've seen on a building, we had a power outage that when the power came back on, there was a weird brownout condition, and it actually didn't fault any of our heat pumps, but our loop pumps didn't come back online, and I didn't have an alarm set up to know that. So I had a system that the building ran for about 36 hours without the ground loop. And when we realized that and our heat pumps started shutting down at their low limit, we reset the pumps and were able to get the ground loop going. I saw that ground loop drop to about 32 degrees for about an hour, and then it recovered by midday. That was the coldest I've ever seen. That was not a condition that was planned for in any way, but it was good for us to watch that happen. And I intentionally did not let that was on our courthouse where we do have a backup boiler. And I wanted to understand how that system would perform without the backup, knowing I could flip a switch and inject heat into the system. I went ahead and ran it without the backup boiler and pushed the limits of that, and the system recovered quite well. And we never needed the backup boiler even in that condition. So yeah, the systems work really, really well.
Well, that's great.
Yeah, I appreciate those comments, because one of the things we see in peer review on a lot of other people's stuff is some people think if a little propylene glycol is good, a lot is better, and that will actually hurt your performance on your system.
For sure. Great questions. We could talk all day on this, but I want to be respectful of everybody's time. We're 10 minutes over. Thank you so much, Terry and John. This has been a great presentation, and I'm sure we'll have a lot of viewers with the recorded session. There's a YouTube icon at the top of the IGSHPA homepage at IGSHPA.org. In 2 or 3 days, you'll find the presentation recorded at that YouTube channel. So join us again for another town hall or dig deeper session. If you go to the website, you'll find an events and training menu, and that's where all of these events are listed. So thanks for your time, everyone. Have a great rest of the week, and let us know how we can help. Take care, everyone.
Thank you. Appreciate it.